What do you think would be the state's?
X1 is phi.
What's X1?
Right. I mean, your first state is
What's that?
the angle of the aileron. So
Right. Would be the aileron. Is the state. Last one pointer. One state. What's another state? B better be a state, because I want to minimum, it's not, so B is a state. Any others?
the rate of change of the aileron, or
Rate of change of what?
the aileron, the
Well, that's input.
Okay.
That's an input. But there's no.
Maybe it's, is it,
What's that?
could it be like the current in the motor? that
Yeah,
could
it's
be-
still kind of input things. I'm thinking of just the airplane, the missile itself. Velocity of the missile. Why do we have velocity of the missile? Well, let's call it velocity of the missile omega, which is v dot, because omega dots equals v watts. J omega dots equal to some torque. All right, there it has physics in here. All right, so omega ought to be a state.
Sorry, which omega is that?
That's phi dot. Yeah, so I have this airplane is rolling, but how does it roll? Well, it's the torque due to the ailerons times the inertia. Right? So we have to have some dynamics, and otherwise it's a trivial problem. Not very good. Yeah.
Would the actual physical, like linear velocity of the missile be a state as well? Because like your torque
Good question.
ratio of the ailerons?
If certainly if that velocity is changing, yes. Well, what are steady state speed? Yeah. A good constant speed, yeah, it would complicate if I had to accelerate or decelerate. But we're up here at cruise altitude, very constant speed. You know, F equals ma of the airplane, not going to matter. It's going to be complicated. All right. All right, so let's get some differential equations here. Phi dot is u, the input. I mean delta. Delta, the function of delta. That's the input for it. Omega dots, I'll write it in this form. Where this tau, it kind of includes the inertia, everything. Essentially, what it is the roll time constant. So lumped all the inertias, everything, frictions, everything under this thing called the time constant. And A, you might say is kind of like the aileron effectiveness. Yes. So state equation is kind of different, but you guys can figure it out. Let's look at the Penrose function. We're going to find Q and the R. Sometimes people like to write 1/2 out here too, because it's quadratic. Not a big deal. Usually don't. Let's think about each of these states individually. One I obviously care about is G. Right. So I want to I'm trying to keep that to be 0. So how would I make a penalty for that? find the Q's and R's here. Individually here first. So I have here, it's going to be squared, it's quadratic. Well, how would I make a weighting function, a weighting factor for that? Any ideas? No ideas? Okay. Think of you after your first class. They give you meals in first class, which is that's a bag of peanuts. Champagne or whatever else they give you. You don't buy first class, I just see them on the phone. And they don't want the champagne to spill. They don't want the soup to spill. So how would they make sure that the soup things don't spill?
You're right, you missed something.
Well, this is what's the guy who fly people off the Mars now, and not even 1%, 0.0001%. So, fly people off the Mars, and they're going to be definitely first class.
Isn't it 1 over the B squared max?
Yeah, it is a max. How much do I work per minute for? I see it used with the astronomer, all of this like he shows. Neil deGrasse Tyson. But he said, mostly about flying on Mars. He says, I'll fly in your rocket after you send your mother. See, he'll send his mother on the flight to Mars. How safe that is. Okay, that makes sense. Maybe I specify some maximum deflection I will allow. Right? What else might I want to cover on this? So we have these states. Let's look at states first. Do they have a penalty on that guy? What about this one, the aileron? Yeah, there's going to be a limit. This is a limit in the aileron. So that might be the max deflection I can have.
Sorry, are we like embedding Q?
Yes, we'll pull Q out of this thing in a second. Yeah, we're going to pull Q out. I'm running all these in squares. What about an angle? Maybe you don't care about how fast it goes. Don't worry about that. Okay? But I have another one I must have in here. What is that? Penalty of what? The input. Must have a penalty for the input. All right? That's greatly inverted. So you might have some new or some max. That might be the max velocity of the motor. Okay? So from this, Q. That's the American or states. The states are in the order of how omega to P. Those are our states. What's P matrix?
One over del X.
1 over max squared. Omega, we don't have. Then we have this one, so that's going to be 0. 1 over B max squared. The zeros everywhere else. Right, so that's our Q. Yeah.
So you said we have to have our input in there because we're
We haven't put the input in there. That's the R.
Right, what I mean is that we have to have that in there because we have to invert.
Yes, exactly right. Yes, because R is inverted. It has to be positive. Definitely. So in this case, it's whatever R max squared is. But this must be positive definite. Now, it might be that it's really, real small, that's okay, but it can't be zero, it can't be big. Make sense for these guys? The higher solution to this thing. We'll go through it. Questions on this? Does it make sense?